Hello everyone, a very good morning all of you and a very warm welcome to you all to this beautiful session on our ISRO 2023 practice session. Can you guys hear me? Am I audible and visible to everyone? Please do let me know through the comment section if my audio and visual quality are fine. Those who are watching me live, please do respond through the comment section. So today we will be discussing the 24 questions from the thermodynamics and its application, and the session is going to be very beneficial for those who are going to appear for ISRO 2023 exam. So do let me know if my audio and visual quality are fine, and also do let me know if you are fully charged up to explore this beautiful session. This is my quick introduction for those who are attending the session for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I cannot see your comments. Please respond. Those who are physically present, mentally present in the session, please mark your presence in the comment section. Either I am not able to receive any comment or you are not writing anything. What is the reason? Is it the technical issue from my end, or is it that you are not responding? Good morning, Vinay. Welcome. So yes, now I am able to see your comments. Naruto, good morning. Namaskar, Adab, Suprabhat, good morning, Sat Sri Akal, Assalamu Alaikum. Please guys, do settle down fast, keep your pen and notebook and try to give your 100% to this session to get the maximum benefit out of it. Right? Shall we start? So those who are here for the very first time, this is my short, sweet and quick introduction. I have also cleared engineering services examination which is conducted by UPSC, worked in Steel Authority of India Limited for a couple of years, and I have also worked in a private consulting firm for more than 2 years. I am quite comfortable in these many subjects of mechanical engineering. If you have anything to discuss, anything to ask, you can always connect with me through the mail ID which is there at the top of the screen, and it will always be beneficial if you join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom of this screen. There are around 1500 students who are part of my Telegram channel. So all are dreaming of qualifying, clearing the competitive examinations. So if you will be part of this type of group, you will get benefits to clear the examination. And we will also support you in every possible way, like the exam notifications, PDF and study notes. The PDF of this session will also be provided to you through my Telegram channel only. The various session updates and the doubt clarification and the important questions are to be discussed on the Telegram channel. All right. So those who are here, keep on responding through the comment section. Then only the session will be lively and I will also feel myself energetic to give my 100% to make the session interesting, simple, easier and fruitful for you. So after this beautiful information, important information, we will be going to start solving the question from the thermal engineering, basic thermodynamics, refrigeration and air conditioning, power plant engineering and IC engine. So there will be around 24 most important and hand-picked questions for improving your fundamentals, for improving your understanding of the subjects. So there will be a workshop tomorrow there is a workshop going to be conducted tomorrow 27th of June at 7:30 p.m. in the evening, taken by Richa ma'am. So the workshop will be completely free. You just have to register yourself and she will be going to discuss the strategy to get the best possible score in GATE 2024, to be among the top 1%. Ashok, Pejal World, welcome guys. Good morning. Welcome to this beautiful session. And you can have the link to register yourself for the workshop. It is already there in the description box. Shall we start? Please make some noise. Please do let me know if you are all ready with your full dedication, with your full positive mindset to explore this beautiful session. Yes or no? Shall we start it? Bataiye. Yes, I want your response. Keep on, be active in the comment section. Great. Let us start with question number 1. This is question number 1 and I want you guys to give me the answer. For a closed system, the difference between the heat added to the system and the work done by the gas is equal to change. Ashok, sometime back also you had asked the same question. One is basic thermodynamics and others are its application. Then applications of thermodynamics involves RAC, refrigeration and air conditioning, IC engine and power plant engineering. So what is the answer? What is the closed system? Closed system is a system when there is no mass transfer is allowed. Closed system does not involve any mass transfer, only energy transfer takes place. Only energy transfer. In a closed system, only energy transfer. The system can be divided into 3 types based on the mass and energy transfer possibility of mass and energy transfer. Closed system, open system and an isolated system. So if it is a closed system, means there is no mass transfer taking place. The difference between the heat added to the system, that is Q, and the work done by the system, Q minus W, will be how much? Will be what? So what is so the question is from the first law of thermodynamics, isn't it? So we know Q is equal to delta U plus W. According to first law for thermodynamics, for a process, this expression, is it valid for reversible process or irreversible process? This expression of first law of thermodynamics, is it valid for reversible or irreversible process? So Q minus W, we can find it out as the change in internal energy of the system. Can you just let me know? Q minus W is equal to delta U. Is it valid for a reversible process or irreversible process? It will be valid. Hi aspirant, welcome. It will be valid for all the processes, whether it is reversible or irreversible. It is valid for reversible as well as irreversible process. But the expression is only for a process, not for a thermodynamic cycle. There is a difference. Hi Nitesh, welcome. Good morning, welcome guys. This was the first question. The answer to the first question is option A. Aspirant, Paisley World, Kiran, Naruto. Well done guys, well done. Keep it up. Let us move to the next one. The condition for reversibility of a cycle. Which expression is correct for reversibility of a cycle? Yes, that is known as Clausius inequality. According to Clausius inequality, cyclic integration of del Q by T. According to Clausius inequality, cyclic integration of del Q by T, if it is less than 1, or sorry, if it is less than 0, if the cyclic integration of del Q by T is less than 0, then the cycle will be irreversible. If it is equal to 0, then the cycle will be reversible, and if it is greater than 0, then the cycle will be impossible. So that is for the Clausius inequality is for reversible as well as irreversible cycle. So according to Clausius inequality, cyclic integration, it will be cyclic integration of del Q by T. Clausius inequality is defined only for a cycle. So for the reversibility, cyclic integration of del Q by T must be, what is the answer? For a reversible cycle, It must be equal to 0. Yes. So Clausius inequality is the basis of definition of entropy. Cyclic integration of del Q by T or del Q by T reversible is called as change in entropy. Do you know that? That is nothing but the change in entropy of a system undergoing a reversible process. So option C is the right answer for the question. Yes, Aspirant, Naruto, Nitesh, Paisal World, Kiran, well done. Good. Let us solve the next question, question number 3 on your screen. Can you guys solve it? The state of a real gas is changed from the pressure P1, temperature T1 to the pressure P2 and temperature T2. The change in enthalpy H2 minus H1 is equal to. Can you guys solve the question? The change in entropy will be equal to. There are 4 options. Is it option A or not? Is it option A or not? It would have been option A. It would have been option A if it would have been ideal gas. The answer would have been option A for an ideal gas. But because it is a real gas, that is why option A will not be correct. That is why it is not correct. So what is the answer? Can you guys solve it? Can we say H is equal to U plus PV? If we differentiate this expression, can we write DH is equal to DU plus P as taken as constant dV plus V as taken constant plus V into dP. So du plus P dV from the first law of thermodynamics, can we write du plus P dV as del Q plus V dP, and del Q can be written as TdS. I told you in the previous question, TdS is equal to del Q. That is for a reversible. By default, we are talking about a reversible process. That is valid for a reversible process. So del Q is equal to TdS, and according to TdS equation, we can write TdS is equal to Cp dt minus V into dV by dt at constant pressure into dP. That is the second TdS equation, isn't it? It will be T, sorry. It will be T. This is the expression plus V dP. This is dH. If we integrate these, or let me first write it as, can I write this dH to be Cp into dt plus V minus T dV by dt at constant pressure multiplied by taken dP as constant. If we integrate from 1 to 2, so the expression will be integration of Cp dt, Cp into T2 minus T1 plus integration of V minus T dV by dt at constant pressure into dP. So the answer will be option D, isn't it? Option D will be the correct answer. Do you understand it or not? This is the expression. This will be the expression, right? The next question on your screen, question number 4. 1/100th of a kilogram. So the mass is 1 by 100 kg. 100 of a kilogram of air is, कौन सा aspirant? Let me explain once again. The enthalpy is equal to internal energy plus flow energy. PV is called as flow energy. We call it as PV as flow energy. This is internal energy. You must know that enthalpy is given by, it is specific enthalpy. So if we differentiate, can we write dH is equal to du plus pdv plus vdp? So this expression du plus pdv can be taken as the del q. Du plus pdv can be written as del q according to first law of thermodynamics. So it will be del q plus vdp and del q will be TdS. So there are two TdS equations. What are TdS equation? Let me write TdS equation. The first TdS equation is equal to Cv dt plus at constant volume into dV. That is first TdS equation. Then another TdS equation, Cp dt minus T into dV by at constant pressure into dP. These are TdS equations, isn't it? So this TdS is written this way, Cp dt minus T into dV by dt at constant pressure into dP. Are you getting it? That is what I have written. This is what I have written. And then between these last two expressions, if we take dP common, so if we take dP as common, then we can write it as V minus T into dV by dt at constant pressure. These are called as TdS equations. Right? Let us move to the next one. Question number 4. 1/100th of a kilogram of air. So the mass is 1 by 100 kg of air is compressed in a piston cylinder device. At any instant of time when the temperature is 400 Kelvin, the rate at which work is being done on the air is, work is done on the air 8.165 kilowatt. It means rate at which the work is done on the system. W dot is equal to, can we write it as minus 8.615 kilojoule per second or kilowatt? Isn't it? And the heat is being removed from the system. So we can say Q dot is equal to minus 1 kilowatt. Isn't it? Both will be negative. According to sign convention, heat added to the system is taken as positive, heat removed from the system is taken as negative. Similarly, work done on the system is negative, work done by the system is positive. So both will be negative. The rate of temperature rise will be, so from the first law of thermodynamics, if we write per unit time, can we say Q dot is equal to delta U dot plus W dot? So Q dot is minus 1 kilowatt, delta U dot minus 8.615. So delta U dot will be equal to, how much it will be? 7.615. Delta U dot is equal to 7.615. Sorry, it is 165. It is 165. 165. So 7.165 kilowatt. So this delta U dot can be written as M into CV into dt by or delta T by tau. This is time. This is temperature difference. Can we write? Because it is per unit time. So dt by t is to be calculated. So delta T by T is equal to delta U dot upon M into CV. So delta U dot is 7.165 kilojoule per second divided by mass is 1 by 100 kg into CV, that is for air it is 0.718, isn't it? That is kilojoule per kg Kelvin. If you simplify along with the units, you will get your unit of your answer will be Kelvin per second. Kilojoule getting cancelled out with this kilojoule, sorry, kilogram getting cancelled out with this kilogram, kilojoule getting cancelled out with this kilojoule. So it will be 7.165 into 100 upon 0.718 Kelvin per second, or degree Celsius per second will also be correct, because we are talking about the temperature difference. Because we are talking about the temperature difference, so either we write it in degree Celsius or Kelvin. Does not make a difference. If the options would have been degree Celsius per second, if the options would have been in degree Celsius per second, then also your answer would have been same. Do you understand it or not? If the option would have been in degree Celsius per second, then also you will not find any difference, any change in your final answer. Because as long as we are talking about the temperature difference, we can either write it as degree Celsius or Kelvin. I hope this is clear to everyone. So what is the answer? So it will be, we can write it as, it is around 0.716 or 0.7165 into 1000 upon 0.718. So these two are almost same. So it is around 1000 Kelvin per second will be the right answer. Aspirant, well done. Nitesh, Faisal World, Kiran had got the exact value. No need to get the exact value though. I hope this is clear. It is about the rate per unit time. The question is about the rate, that is per unit time. So mass into CV into delta T by T will give you the answer for change in internal energy per unit time. Is this clear to everyone? Give me yes. Well done. Great, great. Keep it up. This is beautiful. This question is beautiful. The curve is between volume of the gas versus temperature. The volume versus temperature graph for a certain amount of a perfect gas or an ideal gas at two pressures P1 and P2. There is a pressure P1 which is constant. They are constants. They are same. These are two constant values P1, pressure P1. The gas is same. It is same gas at pressure P1. The graph is 1, and for pressure P2 the graph between volume and temperature for the same perfect gas is 2. Then what can we conclude from that? What can we conclude from this? Yes, Vinay, Pagel World, well done. Can others also solve this one? What about B and C? People are writing A. Why? So if we talk about the slope, what is the slope of the curve? If we talk about the slope, slope is equal to dV by dt at constant pressure. Do you agree or not? If the curve is between V and T, then the slope will be dV by dt at constant pressure. Isn't it? The slope will be dV by dt at constant pressure. Now, because if we talk about an ideal gas, it is an ideal gas, so we can say PV is equal to mRT. Isn't it? So at pressure to be constant, if we differentiate, then what we will get? P into dV is equal to m is constant, r is constant into dt. So dV by dt at constant pressure is equal to mr by p. That is the expression for the slope. That will be the expression. Do you agree 2 is having more slope than 1? Which is having more slope? The one which is more inclined. This is theta 1. This is theta 2. So we can say theta 2 is greater than theta 1. So slope of 2 is greater than 1. Slope of 2 is greater than slope of 1. So can we say mr by p2 must be greater than mr by p1? Isn't it? Slope of 2 will be greater than, 2 is more inclined, it is having more slope. Theta 2 will be more than theta 1. So mr by p2 is greater than mr by p1. So can we say mr is constant? So 1 by p2 is greater than 1 by p1, or can we say p1 will be greater than p2? Do you agree or not? P1 will be greater than P2. I hope this is clear. P1 will be greater than P2. The pressure P1 will be greater than P2. Now what about B and C? The adiabatic index for P1 is higher than P2. What is adiabatic index? That is ratio of specific heats. This is adiabatic index, and adiabatic index depends on the type of gas. It depends on the type of gas. Adiabatic index depends on the type of gas. For an example, if it is a monoatomic gas, it is not a function of pressure. It is not a function. Adiabatic index is not a function of pressure. Adiabatic index only depends on the type of the gas. For monoatomic gas, it is 1.66. For diatomic gas, it is 1.4. For multiatomic gas or for polyatomic gas, it is 4/3, that is 1.33 something. So it depends on the type of the gas. It will depend on the type of the gas. So if the gas is same, so we can say gamma will remain same. The adiabatic index will be same. Whether P1 is more or P2 is more, adiabatic index represents the monoatomic. We cannot say P1 represents the monoatomic gas, P2 represents the diatomic gas. We cannot say from the pressure, we cannot say it is the same gas. So whether it is P1 or P2, it will represent the same gas. Whether it is monoatomic or diatomic, it will not be different at different pressure. I hope this is clear. Yes, aspirant, well done. So that is why option A will be the correct answer for this given question. The next one, question number 6 on your screen. Yes, every one of you, please do let me know your answer. In the polytropic process, PV to the power n is constant. If n is equal to 1, the process will be at, very, very simple question. If n is equal to 1, then if n is equal to 1, then it will become PV is equal to constant. PV is equal to constant. What does that mean? It means temperature is constant. Isn't it? It is temperature is equal to constant. It is temperature is constant. So it is isothermal. If n is equal to 1, it is isothermal. If n is equal to 0, what is the process? If n is equal to 0, what will be the process? For n is equal to 0, V to the power 0 will be equal to 1. If n is equal to 0, then we can say P will be constant. It will be constant pressure. If n is equal to infinite, then V will be constant. It is the constant volume process. And if n is equal to gamma, then it is adiabatic. So n lies between 0 to infinity. The value of n lies between 0 and infinity, isn't it? So if n is equal to 1, it is constant temperature process. If n is equal to gamma, it will be adiabatic. If n is equal to 0, it will be constant pressure, and if n is equal to infinite, it is constant volume process, isochoric process. In case of ideal triatomic gas, the ratio of specific heats will be the ratio of Cp by Cv is equal to gamma. It depends on degree of freedom. This is the expression. F is the degree of freedom for molecular motion. And for ideal triatomic gas, the degree of freedom will be equal to 6. This is the expression. It depends on degree of freedom. The ratio of Cp by Cv is depending on the type of the gas. I have told you, type of the gas means the degree of freedom. So for ideal triatomic gas, F is equal to 6. So we can say Cp by Cv is equal to 1 plus 2 by 6. 1 plus 1 by 3. That is 4 by 3 will be the answer. 4 by 3. How much is that? 1.33. B is the correct answer. Yes, Vinay? B will be the right answer. Let us move to the next one. Question number 8. Next question, question number 8. The formation of frost on the cooling coils in a refrigerator. When does the frost appears on the cooling coil? The frost is appearing when the temperature becomes less than the freezing point temperature. When temperature decreases below freezing point of water. When the temperature decreases below the freezing point of water, then what happens? The moisture gets condensed into ice. Then what happens? The moisture gets cooled and frost appears. Gets cooled and frost appears on the cooling coil. When the temperature of the cooling coil becomes less than the freezing point of water, then the water vapor or the moisture present will get condensed or will get cooled and the frost appears on the cooling coil. That is how the frost appears on the cooling coil. So what happens when the frost appears on the cooling coil? It increases the power consumption because it reduces the rate of heat transfer. In the evaporator, it reduces the rate of heat transfer. So it not increases the heat transfer, it provides an extra layer of thermal resistance. The frost acts as a thermal resistance. So it not increases the heat transfer, it decreases the rate of heat transfer and it increases the power consumption. COP is what? COP is Q2, that is the refrigeration effect upon work input. So it increases the power consumption. If Win increases, then COP will reduce. Then it will reduce the COP. COP will decrease and it will increase the power consumption. Option A will be the correct answer. Well done, Vinay, Vinitesh, Pajal World Aspirant, Naruto. I want every one of you to keep responding in the comment section. Let us move to the question number 9. The next one. The question is from the IC engine, or it is basically the balanced chemical reaction. In order to burn 1 kilogram of methane, complete chemical reaction or the balanced chemical reaction, the minimum number of kilograms of oxygen needed will be Aspirant. The frost appears outside. So to decrease, the frost appears outside. So that is why it is not appearing on the refrigeration or the refrigerant. The frost is not appearing on the refrigerant side. On the cooling towers, there is a refrigerant flowing. So here the frost appears. Here the frost appears. So it will not allow the heat to get removed from the refrigerant. If you want the refrigerant to be cooled to a desired temperature, then we need to give extra power. So the power consumption will increase. Are you getting it? Here there is a frost. Frost appears on the outside of the cooling coils. It is not towards the refrigerant. What is the answer to the next one? In order to burn 1 kilogram of methane CH4, the minimum number of kilogram of oxygen plus O2 will give rise to carbon dioxide and water vapor. This is the reaction. So carbon atoms on the LHS 1, on the RHS 1. Oxygen atoms on the RHS it will be 3, on the LHS it will be 2. So if we make it 4 on the left hand side and if we put 2 here, then oxygen atoms will be 4 on the LHS and RHS and the hydrogen atoms will be 4 on LHS and RHS. So we will put 2 here. So methane, carbon dioxide is having the molecular weight or atomic weight as 12. So 12 plus 4, 16 kg. So it will be 2H2O2. O2 will be equal to 32 into 2, 2 into 32. That is the complete combustion. So 16 kg of methane requires 64 kg of oxygen, and the number of kilogram of oxygen needed. So 1 kilogram of oxygen will be required 16 by 64 kg of methane. Sorry, we want the methane required. The minimum number of kilogram oxygen needed is 1 kg of oxygen What is the confusion here? The minimum number of kilogram of oxygen needed in order to burn 1 kg of methane. 1 kg of methane require 64 divided by 16 kg of oxygen, isn't it? So it will be 4 kg of oxygen. D is the answer. D will be the correct answer. 64 by 16 kilogram of oxygen will be required. The next one, question number 10. What is the answer to the next one? An open cycle gas turbine works on. An open cycle gas turbine works on. Whether it is open cycle or closed cycle. If it is an open cycle or closed cycle gas turbine, it works on Brayton cycle, which is also called as Joule cycle, which is having 2 isentropic process and 2 isobaric process. 2 isentropic and isobaric. So it works on Joule cycle. SI engine is used on Otto cycle, is working on Otto cycle. Carnot cycle is not practically possible. Not a practical cycle. No engine or no equipment works on a Carnot cycle. Stirling cycle is having 2 isothermal process and it is having 2 isochoric process. That is called as Stirling cycle. 2 isothermal and 2 isochoric. So the answer to this question is Joule's cycle, right? This question is simple. When a gas is cooled at constant pressure, if P is equal to constant, what happens? When a gas is cooled, it is a closed system. The cooling of a gas at constant pressure will give rise to. So if it is an ideal gas, we can say PV is equal to mRT. So if the pressure is constant, then we can say V is directly proportional to T. For a closed system, mass is constant, R is constant, V will be directly proportional to T. So cooling means temperature is decreasing. Cooled means there is a decrease in temperature, that will give rise to decrease in volume, or we can call it as compression. There is a compression. Cooling implies compression. So constant pressure compression is same as constant pressure heat rejection. So both temperature and volume decreases. D is the answer. Both temperature and volume will decrease. I hope this is clear. Right? Shall we proceed further? The next question again from the ideal gas law. As per Charles' law, the volume of a given mass of a perfect gas varies as its absolute temperature. The relation between volume and temperature, according to Charles' law, let me tell you, there are three laws which are combined together to give the ideal gas equation. One is called as Boyle's law. One is known as Boyle's law. According to Boyle's law, pressure and volume is inversely proportional to each other for a constant mass. For a constant temperature. Pressure and volume is inversely proportional to each other at a constant temperature. Then comes the Charles' law. According to Charles' law, volume is directly proportional to temperature at constant pressure. Then it is Avogadro's law. Mass is directly proportional to volume, or we can say volume is directly proportional to mass at constant temperature and pressure. These are the three laws combined together to give the ideal gas equation. If we combine them together, PV is given by MRT, or we can say PV is directly proportional to MT. We are getting PV is directly proportional to MT, isn't it? PV is directly proportional to MT and R is the proportionality constant, so it will be PV is equal to MRT. So the answer will be Charles' law says volume and temperature are directly proportional to each other. Option A will be the correct answer for this one. Option A will be the right answer. The next one, in an extensive property change of a thermodynamic system. In an extensive property change. What is extensive property change? What is extensive property? Which depends on mass, which depends on size of the system, which depends on the extent of the system, mass of the system. That is called as extensive property. And it takes place due to change in mass. So it will be due to change in mass. So it, in an extensive property change of a thermodynamic system, extensive heat is transferred. That is incorrect. Extensive means very large amount of heat is transferred. Whether the heat transfer is taking place or not, it does not matter for extensive property, because extensive property change takes place only when there is a mass transfer. Due to change in mass of the system, the extensive property changes, because it depends on the size of the system or mass of the system. So whenever the extensive work is done, work transfer does not guarantee the change in extensive property. Similarly, extensive energy is utilized will not guarantee the change in extensive property. The change in extensive property is guaranteed only when there is a change in mass. So A, B, C all are incorrect. So the correct answer will be none of them. Yes, Naruto, Vinay, well done. Good, good, good. D will be the correct answer. The change in extensive property of a system depends on the change in mass of the system, because extensive property depends on the size of the system. The next one, an actual engine is to be designed having same efficiency as that of Carnot cycle. Such a proposition is, yes. What is the answer? An actual engine is to be designed having same efficiency as that of Carnot cycle. Do you know the efficiency of actual cycle? If it is less than Carnot efficiency, then it is reversible cycle. Actual cycle is reversible. Then actual cycle will be reversible. If it is equal to efficiency of Carnot cycle, then if it is less than Carnot cycle, then the actual cycle will be irreversible. And if it is equal to Carnot cycle, actual cycle will be reversible. If it is greater than Carnot cycle, if the efficiency is greater, then actual cycle will be impossible. So if the efficiency of actual cycle is equal to, Carnot cycle, then your answer should be, the actual cycle should be reversible. Your answer will be reversible. But because no option carries reversible cycle is practically impossible. Carnot cycle is practically impossible. It is not practically feasible. It is practically infeasible. It is a theoretical concept. So because the Carnot cycle is practically infeasible, so that means if the efficiency is same as Carnot cycle, so can we say actual cycle is practically infeasible? So feasible is not correct answer. Feasible or possible, both are same. Desirable is also incorrect because the efficiency cannot be equal to the Carnot efficiency. Actual cycle does not exist which is having the efficiency. It is a theoretical concept. If we can make a completely reversible cycle, then only the efficiency will be same. If the option would have carried reversible, cycle, then your answer would have been, if it would have been reversible in the option, then the answer would have been reversible. Are you getting it? But because no reversible option is there, so that is why option B is more appropriate. Let me tell you, sometimes in theoretical question, you may find 2 or more options looking correct. You may have couple of options looking correct, but the one which is more appropriate for the given situation or for the given question will be treated correct. Yes, it is desirable, but it cannot be achieved. The thing which is practically impossible. So what is the point of having that desire? If you are not able to get the first rank, if you are not able to, so your desire should be practical only, isn't it? You should have a practical desire which can be achieved. The things which cannot be achieved cannot be desirable. Are you getting the point or not? Options are like English exam actually. Feasible and possible both are same options. Feasible and possible, they are same. So A and C will be completely ruled out. Because if it is feasible, it means it is a possible. So A and C will completely rule out. Out of B and D, in my opinion, B is more appropriate compared to D, because the things which are practically impossible cannot be desirable. I hope this is clear. The Carnot efficiency we define only as a reference, that how much is the deviation from the Carnot efficiency, how much is the deviation of efficiency of actual cycle from our reference, that is the Carnot cycle. We do not desire to, we never desire to make it Carnot efficiency. What we desire is to bring the actual efficiency as close as possible to Carnot efficiency. We never desire to get the efficiency of actual cycle exactly as that of Carnot efficiency. We try to make it as close as possible. So because it is talking about the exact equal efficiency, so that desire is, yes, Aniket, This is how you can yes, well done. So B is more appropriate answer to this question. The next one, the next question on your screen. I will share the PDF of this session to my Telegram group. So guys, do not forget to like and share this session so it reaches to all the students who are preparing for ISRO 2023 exam. It is beautiful question. There is a football which is inflated to a gauge pressure of 1 bar. There is a significance of giving the gauge pressure. If we assume the atmospheric pressure, standard atmospheric pressure is around 1.013 bar, or we can take it around 1 bar. So it is inflated to an absolute pressure. What is P1 absolute? That is equal to 2 bar, isn't it? Because in PV is equal to MRT, we always use the absolute pressure. When the ambient temperature was 15 degrees Celsius, so T1 absolute is 273 plus 15 Kelvin. When the game started the next day, the air temperature at the stadium becomes 5 degrees Celsius. So T2 absolute is equal to 273 plus 5 now. Assume that the volume of the football remain constant 2500 centimeter cube. Convert it into meter cube. The amount of heat lost by the air in the football due to this change in temperature. There will be some heat loss. So the amount of heat loss by the air in the football and the gauge pressure of air in the football at the stadium means we need to find out Q loss, that will be given by the first values, and P2 gauge, that will be given by the second values. P2 gauge. So if we find out P2 gauge, try to find out P2 gauge first, or try to find out Q loss, because P2 gauge, two options are having same values for gauge pressure, but if you see Q loss, each option is having a different value. So first of all, find out the heat loss. Can we call it as M into CV, because it is a constant volume process, into delta T. Mass can be written as P1 V1 upon RT1 into CV into delta T. What is P1? Absolute, we need to take the absolute, so it is 2 bar, close to 2 bar, or we could have written 2.013 bar, or we could have written 2.013 bar, 2 bar or 2.013. What is volume? 2500 into 10 to the power minus 6, isn't it? 1 centimeter is 10 to the power minus 2 meter upon R. What is R for air? 287 into temperature T1. What is temperature T1? 283 plus 5, 288 into CV. What is CV? 718 into what did I write? Yes, delta T 15 minus 5, that is 10. So that will be around this much joule. Can you solve it? Can you try solving this one? So if you simplify this, then it will be, so P1 is actually given in bar. Do not forget to convert the way I forgot, 10 to the power 5 Pascal. It will be 10 to the power 5 Pascal. So if you simplify this, so this 10 to the power 5 and these two will get cancelled out. Then it will be 2 into 25, 50, then 00 into around 700 upon 300 into 300. Your answer will be near to this. These two, 4, 1, 2, 3, and then 4. So 350 divided by 9 something. What is 350 by 9? Your answer will be, Q loss will be equal to around 40. It is around 40 joule. Your answer will be around 40 joule. 40 joule. Then one which is having the answer near to 40 joule will be the correct answer. D is the right answer. And how to find out gauge pressure? So we can say P2 absolute is equal to P1 absolute into T2 by T1. So P1 absolute is around 2 bar. T2 is 273 plus 5, 278 by 288. So it will be close to 2, it will be less than 2 bar. So P2 absolute is less than 2 bar. P2 absolute is less than 2 bar. And P2 gauge is less than 1 bar. P2 gauge is less than 1 bar. It cannot be more. Gauge pressure will be less than 1 bar. So it is 0.93 bar. D is the answer. D will be the answer. I hope this is clear. This is how, without using the calculator, you can. The question is to find out the gauge pressure. It is about the gauge pressure of air. Absolute pressure will be less than 2 bar. Absolute pressure is close to 1.94 bar. Absolute pressure at point 2 will be 1.94 bar. But the question is about the gauge pressure. That is why 0.93 will be the correct answer. Option D will be the right answer for this one. The next question, for a thermodynamic process to be reversible. If we want a process to be reversible, the temperature difference between hot body and working substance should be. The temperature difference. Whenever there is a temperature difference, it gives rise to the heat transfer. So for a reversible process, for reversible heat transfer, it should be isothermal. If we want the reversible heat transfer, it should be isothermal process. So the temperature difference will be almost zero. The temperature difference should be almost zero. The heat transfer will be reversible only when it is isothermal or due to very low temperature difference. The temperature difference between the hot body and the working substance should be very, very low. It should be infinitesimally very small. The temperature difference that can be taken as almost zero. The temperature difference will almost be zero, infinitely very small. So the answer will be 0. Infinitesimally very small. Isothermal heat transfer is called as reversible heat transfer. The next one, for a rotary compressor are used. Rotary compressors are centrifugal compressors, which are having the rotating unit, rotor. Rotary compressors are used to deliver large quantity of air at low pressure. Rotary compressors are used to deliver large quantity of air at low pressure. And small quantity of air at high pressure is by translatory compression. If it would have been translatory compressor or reciprocating compressor, it would have given the small quantities of air at high pressure. So B will be the answer. The next one, an aeroplane is flying at a height of 12 km where the temperature is minus 35 degrees Celsius. The speed of aeroplane is corresponding to Mach number 2. Find the speed of the plane if the R value of R and its specific heat ratio is given. What is the speed of plane? V. V is the speed of plane. Mach number is equal to V by C. We can write V is up under root of gamma RT. So V is equal to M into under root of specific heat ratio into R, characteristic gas constant, into T. So put the value 2 into under root of gamma is around 1.4, R is 287 into absolute temperature. It is 273 minus 35. So it will be 273 minus 35. 35 Kelvin. So it will be 238. So it will be around twice of under root We can call it as 300 into 300, around 300 into 300. So it will be around 2 into 300, around 600, around 600. The one which is near to 600 will be the answer. It will be greater than 600. It will be greater than 600 because 238 into 1.4 is greater than 300. So the answer will be option A. A rotary compressor, again it is about the centrifugal compressor, is driven by electrical motor as well as engine. We can use the engine to drive the rotary compressor. We can use the electrical motor. Both are correct. So both of them, option C will be the right answer. All right. So let us quickly solve the remaining question and the session will be over. In a centrifugal compressor, an increase in speed at a given pressure ratio. When the speed gets increased, it will deliver more discharge. It will increase the flow rate. But due to high flow rate, there is a chances of shock waves. So it will decrease the efficiency due to shock waves. It will increase in the flow and decrease in efficiency. D will be the answer. A large clearance volume, if the clearance volume VC is very large in a reciprocating compressor, it will result in low volume flow rate because the volume flow rate is corresponding to the swept volume. Volume flow rate is corresponding to the swept volume. So if VC is very large, if VC increases, so we can say VS will decrease. So it will reduce the volume flow rate. The next one, second last question for the day. If the air fuel mixture ignites before the spark takes place at a spark plug, the condition is called as. If the air fuel mixture, it is in SI engine. The burning of air fuel mixture before the actual initiation of the spark plug, before the initiation of a spark, that is called as pre-ignition, and that happens due to local overheating due to detonation. If there would have been a detonation, then due to detonation there will be high temperature, and due to very high temperature there is a chances of pre-ignition taking place in the SI engine. C will be the answer. And the last question says the diagram which shows the correct crank position corresponding to the opening and closing of the valve. The correct crank position corresponding to opening and closing of the valve. Yes, aspirant, knocking takes place in SI engine. Knocking takes place. It is the answer will not be knocking or detonation. Why? Because knocking takes place at the end of combustion. In SI engine, knocking takes place at the end of combustion. And due to combustion or due to knocking at the end of combustion in the next cycle, there will be a chances of pre-ignition because of local overheating of the air fuel mixture. So the diagram which shows the correct crank position corresponding to the opening and closing of the valve is called as valve timing diagram. Option C, it is the valve timing diagram. Indicator diagram is for efficiency or the performance. Indicator diagram will be measure of performance of the engine. Right? So option C is the right answer. So that is all from my side. I hope you guys have enjoyed. You can always connect with me through the mail ID, and do not forget to like and share this session. And if you are not part of my Telegram channel yet, please do join me on the Telegram. That is Mechanical by Chandrasekhar. The link is also mentioned at the bottom of the screen. Thank you for joining in, guys, and see you in the next such session. Till then, enjoy, take care, have a good day and a great career ahead. These are few series which are already running on our BYJU'S YouTube channel. All right. So see you guys. Till then, have a good day and keep preparing and keep yourself motivated to crack the ISRO exam. Jai Hind.